Okay, so for chapter 4, we're actually going to look at fiber analysis. Fiber analysis, much like in the prior chapter with hair analysis, can link a suspect or victim to a crime scene or with another person or object. Since we wear clothes and have hair, we shed fibers. The crime scene investigator looks for these small fibers that portray where a suspect has been and with whom they may have been in contact with. Now, when we look at fibers overall, hmm, fibers are going to be the smallest unit of a textile material, and when spun together, they form yarn. We have natural fibers and synthetic fibers. Natural fibers would include things that are like plants, which would be cotton, animals, which could be wool, or minerals. Synthetic fibers, these are manufactured items, and this would be like nylon or spandex or things like that. Elastic. So, fiber evidence is considered class evidence. It is an important source of trace evidence. An early collection is critical within 24 hours. An estimated 95% are lost from a crime scene if it's not collected early. So that's why early collection is very important. Early fibers go way back. Linen was woven in Egypt as far back as 4400 BC. Silk was woven in India in 1700 BC. Rayon and acetate became the first man-made or synthetic fibers. And today, polymers of hundreds of types of synthetic fibers are manufactured with different combinations and blends, and all giving very unique, um, all giving very unique um, compositions. Now, when we do the analysis of the fiber, we have physical, chemical, and microscopic analyses. They are mass-produced fiber, provides class evidence, and forensics organizations have improved protocols and guidelines for how this should actually be done. Okay. Within court proceedings, examiners may offer one of the following three conclusions. One, it was inclusive. Two, exclusive. Or three, inconclusive. And you really want to avoid statements like reasonable degree of certainty because with fibers, it's not going to be 100% certain. Again, this is a class evidence, not an individual evidence. Um, Inclusive means that it can be included or was part of the crime scene. Exclusive means you can exclude somebody. Inconclusive means you can't make a conclusion one way or another. Now, if we look at the science of fibers, we have our natural fibers. These are animal fibers such as hair, fur, silk from silkworm. Plant fibers such as starch molecules called cellulose. Cotton is a very common one. And then mineral fibers, these would be crystalline materials, which are neither protein nor cellulose based. Your synthetic or manufactured fibers are produced by joining of many polymers together. They are regenerated fibers or modified natural fibers. And synthetic polymer fibers could be polyester, nylon, acrylic, olefins. If you look at many of your own clothing, you might find some of these things present there. Now, some characteristics of fibers. Natural fibers are environmentally safe, but they are also biodegradable. Synthetic fibers can be produced year-round at a much lower cost, and they're not as biodegradable as, say, natural fibers. And then blending is when you take both natural fibers and synthetic fibers, which most manufacturers will sort of take the best qualities from each to create a new type of blended fiber. Now, if we look at our yarns, these may be spun together. Very thin yarn is often referred to as a thread. Rope is oftentimes a very thick yarn, and forensic scientists will analyze the twist direction as part of their identification when looking at these types of things. Excuse me. So looking at textiles, you can look at the different types of fibers that are used for the weaving of the textile. The actual weaving or weave patterns. Is it plain, twill, satin? And what's the overall thread count as well? These are all characteristics that can be used in the identification of particular types of fibers, yarns, and textiles. Now, collection of fiber and an investigation. Fiber evidence recovery, rugs, furniture, clothing, cars, household objects are areas that you might want to look at. Collection in the field and in the laboratory, large objects from which fibers were removed, box, seal, and send to the crime laboratory. So, for example, if you had somebody that was maybe in a car, or was on a rug, they might have some of those trace fibers now on their own clothing, and that can be analyzed. And then if it is something that can be identified as part of a crime scene, that's just adding more evidence to the pile here. When they analyze fibers, they'll do some microscopic analysis. Natural fibers can be distinguished using an ordinary light microscope. Because of the nature of synthetic fibers, they do not have any internal structures which can be sort of analyzed. They must be viewed in a cross section underneath of an electron microscope, as shown in the image here. You can also look at the chemical and physical analysis of fibers. The chemical composition and the quantities of chemicals in fibers. This can be done by looking at gas chromatography and mass spectrometer, which will allow you to sort of identify the various compounds that make up a particular fiber. This does, however, require very expensive equipment and a chemist to sort of use that type of equipment. And you're also comparing known fibers to unknown, or unknown fibers to known fibers. You need to have sort of a database that you're sort of comparing these two. Now, when you look at fiber analysis, the value does depend on its uniqueness. White cotton will have less value than Angora. With only one fiber as evidence, it cannot be damaged or altered. So if you're looking at a typical Hanes white t-shirt, that's not probably going to be very valuable versus a very unique woven rug that might be. Forensic scientists will consider the following: the type and the color of the fiber, the number of and where the fibers were found, the textile from which the fiber originated, were there multiple fiber transfers, the type of crime that was committed, and the time between the crime and the actual discovery of the fiber. There are also various non-destructive techniques. For example, MSP combines microscopy with UV and visible light spectroscopy, and it is capable of analyzing very small samples. Fourier transform infrared analysis. This is selective absorption of wavelengths of light, again, which is going to be useful for identification of composition of the hair of the fiber. So in summary, fibers are a form of class evidence. Fibers are spun into yarns that have specific characteristics. The yarns are woven or knitted with different weave patterns, and fibers easily can be overlooked or transferred directly or by secondary transfers. The potential for fiber transfer depends on several factors. Forensic fiber analysis has shifted to more objective chemical analysis. However, fibers are classified as synthetic or natural fibers, including animal hairs and fur, and synthetic fibers, which can include regenerated or modified natural fibers. Clothing that's made from natural fibers tends to be more comfortable. Thread counts and weave patterns help to distinguish one textile from another. Evidence must be dried before bagging, or otherwise you'll end up with that mold situation that we talked about with the hair follicles. Natural fibers such as cotton, silk, and wool have distinctive identifying characteristics. And then fibers may be analyzed using polarized light microscopy, infrared microscopy, UV light, and electron microscopy. New technologies enable minute fibers to be chemically analyzed without destroying the fiber itself. And that is the end of this chapter.